A popular tool in any utility closet, the spring-driven retractable tape measure was invented in the middle of the 19th century. But it didn't really become popular until the 1940s. Today, any handyman without one just doesn't measure up. Measuring tapes take the guesswork out of any job. And if you don't use one, you'll soon see the error of your ways. Production begins with a three-dimensional computer design. To bring that vision to life, a machine first pulls hardened strips of steel, 5 at a time, across a network of rollers that coat them with primer. Then comes the paint. After the paint dries, the strips are rewound in preparation for printing. Printing cylinders roll the measurement markings onto the steel strips. They use black ink for millimeters and red for meters. Next, they heat the measuring tape. This ensures that the protective plastic film applied by this machine will stick well to the steel. Rollers then give the tape a concave contour so that it can be extended rigidly. Every few seconds, the presses grind to a halt, and a blade cuts the tape to the correct length. At the same time, it punches a hole for the end hook, which is then riveted into place. Another machine rolls up steel to make springs. The spring enables the measuring tape to retract into the casing. The end of the spring is clipped to an automatic winding machine. A worker places the lower half of the tape measure's casing into position. The machine then rewinds the steel spring and transfers it into the casing. The spring gets a little lubricating oil. Then workers install the control brakes, which can be used to lock and unroll tape in place. Assembling the rest of the casing is a snap. Everything is screwed together. The measuring tape is attached to the spring. And then it's time to test that spring action. This factory makes some longer measuring tapes from glass fibers, which are far lighter than steel. Multiple strands of glass are pulled through a tub of white liquid plastic so that they'll stick together. The fibers then enter a machine that coats them with more plastic, melted down from hard pellets like these. This process transforms the glass fibers into a strong yet flexible tape, the type commonly used for surveyors' tape measures. A computerized printer transfers measurements to the tape a meter a second. Lights illuminate the tape so a camera can check for printing defects. An inspector double-checks the print job and also examines each tape for accuracy. Some tapes are more accurate than others because of varying standards in different industries and different countries. She grades each tape and marks it so that it can be tracked back to the operator. A laser then moves over the tapes to check the accuracy level again. If the reading is off by even a few thousandths of a millimeter, then the tape is rejected. Winding a surveyor's tape is a manual job. No spring system here, because that would make the tape measure too heavy and unwieldy. After winding, the tape is cut and the end hook is fastened into place. And finally, these measuring tapes are ready to roll.